Hi, in class on Friday I stopped our in-class exercises to do an example of substitution with a definite integral, illustrating the two different ways it can be done. I thought I'd make a video for this. Let's say you have the integral from 0 to 2 of x over 3x squared plus 2 cubed. Well, certainly not something that we know how to take the derivative of. If you want to do it completely directly, we're going to do u substitution. We have to convert everything here from x's into u's. We say u equals 3x squared plus 2, then this 3x squared plus 2 cubed down below is going to become u cubed, something that we do know how to take the derivative of. We're going to have to turn the dx into a du. Well, du is 6x dx. We don't have a 6x dx, but we can say that x dx is 1/6 of du. Well, that will turn everything over here into u's. However, this is x equals 0 and x equals 2. We say if x is 0, then u is 3 times 0 squared plus 2 is 2. See, because u is 3 times the square of x plus 2. And if x is 2, then u is 3 times 2 squared plus 2, which is 4, 12, 14. And that means we have to convert everything over. This this x equals 2 becomes u equals 14. This x equals 0 becomes u equals 2. This x dx becomes this 1 over 3x squared plus 2 cubed becomes 1 over u cubed, and the x dx becomes 1/6 du. We clean this up a little bit, put the 1/6 out front, call this integral from 2 to 14 of u to the minus 3 du, and we integrate that by saying that this is 1/6 of u to the minus 2 over minus 2 from 2 to 14, and that is what? Negative 1/12 of u squared from 2 to 14. We can pull the negative 1/12 out and say this is 1 over 14 squared minus 1 over 2 squared. I don't feel really like figuring that out. You can do it on a calculator. Good enough. Good enough for me. Now, this is what happens if you convert the limits of integration, the 0 and 2. You turn that from x equals 0 up to x equals 2 into u equals 2 to u equals 14 using some kind of reasoning like this. There's another way. Another way is, and I almost say, well, since we're talking about this, the integral, the indefinite integral, 3x squared plus 2 cubed dx, if we didn't have the limits of integration, we would follow the same sort of pattern. U equals 3x squared plus 2, du is 6x dx, x dx is therefore 1/6 of du. We don't worry about the limits of integration, and this becomes, we can put the 1/6 out front, then we have 1 over u cubed du. Right, the 1/6 du is the same as the x dx, and the other thing. So again, this is 1/6 integral of u to the minus 3 du, which is 1/6 u to the minus 2 over minus 2 plus c, which is, what is it? Negative 1 over 12 u squared plus c, which we bring back into x's, so it's negative 1/12 of 1/12 3x squared plus 2 squared plus c. And if that's the case, what were we integrating from 0 to 2? Thus, the integral from 0 to 2 of x over 3x squared plus 2 cubed dx is negative 1 over 12 3x squared plus 2 squared from 0 to 2, which is, pull the 1/12 out front because both of these have a 1/12, and we have 1 over 3 times 2 squared plus 2 squared minus 1 over 3 times 0 squared plus 2 squared, which is negative 1/12 of 4/12, 1 over 14 squared minus 0, 1 over 2 squared. Also known as 1/4. But we get the same answer. A definite integral is a definite number. What is the area between that curve and the x-axis between your limits of integration? X equals 0, x equals 2 in this case. And you get an exact number. This will turn out to be a negative number. Nope. Hold on. Nope. 1 over 14 squared is smaller than 1/4. So this number in parentheses is negative, and you put another negative out front. So more of the curve is above the x-axis than below. Yay! And that's just your two methods. I generally prefer to do it. See, it looks like it was shorter. I'm going to do it both ways. If it looks like a whopping pain to convert the limits of integration, I'm going to evaluate it without. But remember, the thing I want to say is, you can't say that if you are evaluating this, it's equal to this, because this is the antiderivative of a function. It turns into a function, a plus c, that kind of thing, a function with plus c, whereas this is a specific number, the area under a curve. So these are different things. These are not equal, and they can't be equal. So if you want that integral from 0 to 2 to be equal to something, you are going to have it equal to something whose limits of integration are in terms of your variable u, and that's going to require conversion.